Hello YouTube. In this video we're going to be discussing how we convert angle measurements from degrees to radians and vice versa. For many reasons. One, because sometimes we're just given information in degree form and we need it to be changed into radian format, but also because crabby high school kids a lot of the time like to complain about radian measurement and would rather deal with them in degrees. And that's right, I said crabby. I get crabby too. It's all good. But here we go. Yeah, converting from one set of units to another. Let's just go and start with this concept because often I get questions. I have like medically inclined kids, and we say, well, how would I convert from, like, for example, how many number of miles to number of feet in a mile. So for example, like that. Okay. What if I had like 2.5 miles to begin with? 2.5 miles, and I want to convert this into number of feet. The method for doing so is this. Well, first of all, acknowledging that when we get done, we would like to have a number of feet on top of our fraction here. That's what I want. I want feet to be on top. But the fact of the matter is this. In order to convert from miles to feet, basically we need to get the miles to pick up and leave. We need to get them to go away, cancel out these units, okay? So you notice miles are on top here in this fraction. We need to get it to go away. Two different things we could do, but we know one thing. We know that 1 mile, okay? We start with our unit conversion, our ratio here, is equal to 5,280 feet. That is the case, ladies and gentlemen. So what we can do is this. We can take our original fraction here, and we can multiply it by this ratio. The fact of the matter, though, is this. We can multiply by 1 mile over 5,280 feet, or we can multiply by 5,280 feet over 1 mile, since these essentially, they mean the same thing. So the question is, would I want to multiply by 1 mile over 5,280 feet? 5,280 feet. Sorry about the sloppiness of that. Feet, or would I want to multiply by 5,280 feet over 1 mile? Either way, I haven't really changed the values here. But you'll notice that in the second way, we have miles on the bottom. And so that's desirable because when I write this out, we say, okay, so 1 mile is equal to 5,280 feet. What you see is essentially this. Your miles, you get them to pack up and leave town, and now we can just multiply this straight across. We say 2.5 times 5,280 feet. It wasn't really the value that I was after here. I mean, we could find that as like 1,000, I don't know, 1,560 plus another half of 2,640. It doesn't matter. It doesn't matter. Ladies and gentlemen, this kind of makes sense here. We say, well, 2.5 miles, it's like saying 2.5 of these groups of 5,280. But the bottom line is this. You're left with feet on top, and that's what we wanted. We wanted to go to feet. So when we discuss conversions, we're really going to take what we have and try to multiply it by some identity ratio. That is 5,280 feet, 1 mile. They mean the same thing, so we can write one over the other, and it's not going to change a darn thing. But we're going to try to write it in such a way that we get our units to cancel out and leave behind what we want. So let's go ahead and start with what we're converting from and to in this video. In this video, we're going to be going from degrees to radians and radians to degrees. And the one thing I want you to notice is this. When we talk about degrees, we tend to write that little degree mark in the top right corner. When we talk about radians, we have a pi. And those are like our units in this instance. Okay, so let's go ahead and start with an easy angle, one that we're very, very familiar with. How about a 45-degree angle? We say theta is equal to 45 degrees. Now we'll go ahead and do some foreshadowing here, but we also know this. That's the same thing as a fourth of pi, or since pi radians is the same as a 180-degree rotation, then a fourth of pi would be 180 divided by 4. It's 45 degrees. We'll go ahead and sketch this even. So we say 45-degree angle, simply put, that's like right here. The reason why this is also a fourth of pi, because if pi is a 180-degree rotation, then we say that's a fourth of the way there. We could split that up into 4 equal-sized pieces. Yes, we could. Anyways, moving right along, 45 degrees equal to pi fourths. We want to go from, say, radians to degrees and degrees to radians in some instances. So this is just an example before we write down a general outline of how you do this. But let's say we started with 45 degrees and we had some cranky math teacher asking you to convert it to pi fourths and you didn't know how. Let's think back to what I said up top about conversions. Starting with the fact that I have 45, in this case I'm kind of saying like our unit is like this degree thing here, 45 over 1. The fact of the matter is I can take this times some sort of identity ratio, and that is like saying, well, I could take this times 1 mile was the 5,280 feet because they meant the same thing. We could also say this. We know that pi radians is the same thing as 180 degrees. Or we could even say we've got 180 degrees is the same thing as pi radians. We could take it times either of these. It's really like taking it times 1 because you're saying one thing divided by the other thing and they're equal. It's just we're using different units. The question in this instance though is, would we want to take our 45 degrees down here times pi over 180 degrees or 180 degrees over pi? So two things we want to admit here. First one is this. We want this to come out to have radians on the top when we're done. Okay, that's kind of a key thing. And the other thing is we would like for our degrees right here to cancel out with degrees down here. So out of both of these options, it makes more sense to take this times pi over 180, which accomplishes the two things we wanted. We wanted those degree marks to cancel out, and we wanted to be left with pi on top. So in this case, we're not actually done canceling. You'll notice that 45 and 180 share a common factor of 45. That is, we could say 45 goes into itself one time, 45 goes into 180 4 times, and so on top we have 1 times pi is pi, so 1 pi, and on the bottom we have 1 times 4. Look at that. We ended up with our pi fourths radians. Now conversely, what if we had wanted to go from pi fourths back to degrees? Well, we're going to multiply this either by 180 over pi, 180 degrees over pi, or pi over 180 degrees. In this case, we want our radians to cancel out, so it makes more sense to say, well, then we'll multiply this by 180 degrees over pi radians. This is really essentially right here, this is like saying 1, because they mean the same thing. You're dividing something by itself, but just with different units. So in this case, we get our pi's to cancel out. We have 1 and 1, and we say, well, 4 goes into 180 45 times, and the degrees are still up here, and it goes into itself once. So on top we have 1 times 45 degrees is just 45 degrees, and on the bottom we have 1 times 1 is 1. So how about a general outline, Mr. A? Well, I'll tell you what, the fact of the matter is this: if we want to go from degrees to radians, the general principle is this: multiply. Write this down. Multiply degrees to radians. Since we want to go to radians, we'll put the radian value on top. We'll multiply by pi over 180 degrees. This always works. And if we want to go from radians to degrees, it is the case that we want to multiply by the reciprocal of what we've just written. Multiply by 180 degrees over pi. Why, or how am I going to remember this? Well, if you're going 2 degrees, we want degrees on top. Okay, then we're going to put our 180 degree number on top. If we're going 2 radians, we're going to put our pi number on top because that deals with radians in general. So the fact of the matter is, this is always what we would do. So what if now I've got to say, for example, 270 degree measurement. I want to go to radians. Okay, so since we're going from degrees to radians, we'll use this first measurement here, and we say, all right, we'll convert by multiplying by pi over 180 degrees. We can make this both into fractions here. We say our degrees cancel out. We say, well, I notice 90 goes into 270 3 times. I notice 90 goes into 180 twice. And so we end up on top with 3 times pi, and then on bottom 1 over 2, or 1 times 2, so 3 pi halves. Now keep in mind a pi halves rotation. You know, just kind of back this up here. Pi halves would have been a 90 degree rotation. So we're saying we have 3 of those, so 90 plus another 90 plus another 90. There's our 3 pi halves rotation that we just ended up with here, which is the same as a 270 degree angle. Okay, so let's do uno más, one more. I want to go to from degrees to radians. So thank you for bearing with me here. I'm going to do something interesting. I never write on a white background. This is going to be kind of different for me. I have to admit, I don't know if the guy ever actually watches my videos, but Sal Khan, I mean, I stole the format of the way I write my videos up from him in terms of the opaque background, but he's an awesome guy. I like that guy. So what if I wanted to go from not degrees to radians, but radians to degrees? What if I had like a 7 pi sixth radian measurement? I want to go to degrees. So we'll take this time. Since we're going 2 degrees, we'll put our 180 degree number on top here, and we'll put pi radians on bottom. So we see that our radians cancel out. We say, well, any common factors we can cross cancel. We say, well, 6 and 180, 6 goes into itself 1 time, uno tiempo. And we say 6 goes into 180 30 times. Okay, so we say, all right, so 7 times 30 degrees is 210 degrees, and on bottom we just get 1. So really, when we talk about talk about a 7 pi 6th radian measurement, we mean the same thing as 210 degrees. And just to back this up, I can draw big because this is my last example. Pi 6th, why don't we do a darker color here? Blue, yes, okay. Pi 6, well, 1/6 of pi, well, if this is pi right here, oh, we wanted blue. We say 1, 2, 3, 4, 5, 6, like 6 pi 6 plus another 1/6 of pi. There's our 7 pi 6 degree, 7 pi 6 radian measurement. 7 pi 6, of course, we just determined was the same thing as 210 degrees. Why do I want to know how to convert back and forth? Again, I'm going to be honest with you, there are times where we get hooked up with a number like 210 degrees and we need it as a real number. Remember, degrees are imaginary things, okay? Radians are real. Keep it real. And sometimes we want to go from radians to degrees because, well, let's face it, it's easier to think about things in degrees from time to time.